acceleration.
Okay.
Like velocity, we have velocity, the average velocity and the instantaneous velocity. So we also have this average acceleration, and of course we have instantaneous acceleration. But in this case, we are only learning about constant acceleration. The acceleration may change, but in this case, we are only learning problems with constant acceleration. Okay, right.
Okay.
So we look at the definition of average acceleration. The average acceleration is given by the symbol A with a bar at the top. So this bar denotes average acceleration, right? A bar. Now it is defined as the change in velocity over the time interval. Now change in velocity is, as usual, we use the delta notation. Delta V over delta T. So the change in velocity divided by the change in time or the time interval. Okay. Then what is the change in velocity? It is the initial velocity, the final velocity minus the initial velocity. That means after traveling for some time, the you start timing that velocity. Okay, that is the initial
Mm-hmm.
velocity, and finally you reach certain velocity, that is the final velocity. Okay, so during that time, the difference in time is final, the time minus the initial, the time.
Okay.
Okay, now we are going to look at a real example. Okay, so we look at this figure 2.8. Figure 2.8 shows a car moving to the right. Okay, acceleration from a velocity of vi, initial velocity, to a velocity of vf, and the time taken is tf minus ti. Okay, right.
Okay.
So in this problem, let's say at first the time is t seconds. You start timing with your stopwatch. So the time is 0. You start to press your stopwatch, and at that time the car is already traveling with a velocity of 10 meter per second. Okay. Then after 2 seconds, like you look at your stopwatch. Then after 2 seconds, the velocity now is 20 meter per second. Okay, so what is the average acceleration during this period of time, the from t0 to t2? So we use the definition of average velocity, that is delta v over delta t. So to
Okay.
find the delta v, we use this final velocity 20, okay, minus the initial velocity 10. So it's 20 minus 10, and the time taken is 2 second minus 0 second. So it is 10 divided by 2. Okay, 10 divided by 2 is 5 meter per second square. Meter per second square, it can sometimes it can be written like this, how to write. Now in certain books, they write it this way: meter per second, the unit. They don't use the stroke, where is it? They don't use the stroke, they write it this way. And most of the textbook that I come across, our local textbook, it is written like this. It is written without the stroke. They space out the two different unit, meter second. Instead of putting a stroke there, they put -2. Have you come across this type of notation for meter per
Yeah.
second?
Yeah. Yeah.
Yes,
Mm-hmm.
so but I don't know. Most of the time, that most of the textbook I see is use this type of notation. uh, I seldom see them. this is actually the standard notation, the meter second. Per, instead of writing per, they put a negative sign there. Okay, never mind. So now let us now analyze the motion of this car. Now the positive sign means the car is increasing its velocity at 5 meter per second for every second. Oh dear. Oh, no. My, where is it? Okay, remove this first. Okay, right. Now, velocity is, the acceleration is positive. The acceleration is positive means the velocity is increasing. Okay,
Okay.
positive velocity here. It means that the acceleration means the velocity is increasing. Okay, another thing is the car is traveling. If you look at this car, it is moving in the positive direction. It is moving in the positive direction from left to right, from left to right. So the velocity, they are all positive. They are all positive, and they are moving in the positive direction, and they are increasing the velocity. So you have acceleration being a positive number. Now, if the car is moving from left to right, okay, and you have a negative velocity, a negative acceleration, sorry. Now, if there's a negative acceleration, it means that the velocity is decreasing. Okay, so there are two things that you need to take note: positive acceleration and negative acceleration. Positive, as if it is moving in the positive direction, okay, if
Okay.
it is moving in the positive direction and the acceleration is positive, it means that the velocity is increasing. If
Okay.
the acceleration is negative, it means that the velocity is decreasing. Now we look at another example, which is slightly different, huh? Now, if you look at the second example here, okay, now you see the car is moving from right to left. The car is moving from right to left. The velocity is negative. Both the velocity is negative, right?
Mm-hmm.
At first, the velocity is negative 10, right? Finally, the velocity is negative 20, negative 20. Now, if we use our definition of average acceleration to find the acceleration of this car, okay? So we should use negative 20 minus 10, minus negative 10, sorry. So it's negative 20 minus negative 10. The time, not so confusing. We use 2 minus 0. 2 minus 0. Okay, let me explain. So at first we use this. Okay, at first we use negative 20 minus negative
Okay.
10. So this is the top part. Then for the time, you use 2 minus 0. And you see that the average acceleration is a negative number. Now, does this mean that the car is, the velocity of the car is decreasing?
Yes.
Well, the acceleration is negative. So is the car
Mm-hmm.
decreasing its velocity? Now, if you look at the diagram here, initially it is only negative 10.
Okay.
Finally, it is negative 20. Okay, finally it's negative 20. Now, actually the velocity is increasing or decreasing?
Increasing.
Huh? No,
Yes, increasing.
I mean, let's say you talk about the speed now. Let's say you talk about the speed. The velocity is negative 10. The speed is 10 lah. Then when
Okay.
the velocity is negative 20, the speed is actually 20. So the speed from 10 to 20. From 10 to 20, the speed. Is the speed increasing or decreasing?
Increasing.
Huh? From the speed from 10 to 20, increasing or decreasing?
Increasing, no?
The speed is actually increasing, but because of the direction, because it is moving in the from right to left, we have to use the negative sign there. But the
Mm-hmm.
true speed is actually increasing. And
Okay.
because of this negative sign here, we end up having a negative acceleration. Having a negative acceleration. So- But the speed is increasing. So it means you have to be very careful, right? Let's say, okay, you listen. If it is moving in the positive direction, that means from right, from left to right, it is moving in a positive direction. If it has a positive acceleration, it means that the velocity is increasing. If it has a negative acceleration, it means that the velocity is decreasing. Now,
Okay.
however, if the car is moving from right to left, that means like in the second example here. In the second example here, if it is moving in the negative direction and the acceleration is negative, actually the true speed is increasing. If the as in the second case, if the acceleration is positive, then actually the true speed is actually decreasing. Okay? It is in the
Okay.
opposite way. So over here, I say that the sign means the negative sign means the car is increasing its velocity at 5 meter per second for every second in the negative direction. Okay, so if the
Mm-hmm.
car is traveling in the negative direction, the negative the negative acceleration means actually the speed lah. I don't mean the velocity. The speed is actually increasing. If the acceleration is positive, it means that the speed is decreasing. Okay, so it depends on which direction you are traveling. If you are traveling in a positive direction, okay, fine. Positive means you are increasing the velocity. If you are traveling in the negative direction, negative means increasing the velocity. Before I carry on, can you have any questions to ask or not?
No, no, no. I
Then,
understand. I
then you
understand.
ask. You think about first.
No, I understand. I understand.
Understand? The
Mm-hmm.
negative actually doesn't when it is moving in the opposite direction, it doesn't really mean that the velocity is increasing or decreasing. It is the reverse. It is the reverse.
Mm-hmm.
Okay, right. Then in this one, they have quiz 2.2 here. So you have to answer
True or
true
false?
or false. You read the question and see. A car,
A car must always have an acceleration in the same direction as its velocity.
a car
No.
must always have an acceleration in the same direction with its velocity. So not necessary. Sometimes you are traveling in the same direction. Sometimes your car is increasing its velocity. Sometimes it is decreasing. So it's not necessarily
Okay.
accelerating. Okay, right. Now, part B.
It's
Part B.
it's possible for a slowing car to have a positive acceleration. True.
Okay, this one is true. It is possible for a slowing car to have a positive acceleration. So this B here, part B, is actually referring to this problem here. Although the car is slowing down, it is not increasing the speed, it's slowing down, but the acceleration is actually negative, right?
Okay.
An object with constant non-zero
Non-zero.
acceleration. You read and see.
Non-zero. A constant with An object at constant non-zero acceleration can never stop and remain at rest.
Okay. Now, actually, for all these three questions, they are actually referring to this one, the gravitational acceleration. Okay. Now, let me explain this gravitational acceleration. Now, you consider you are throwing a ball up vertically upwards. You throw a ball vertically upwards. So your upward journey is shown here on the left hand side. All this is your upward journey, right? All this side is your upward journey. All this side is your upward journey. Okay, so your ball is moving upward, so the velocity is given by the green arrow. Now, however, the acceleration is acting downward because of the gravitational pull. So
Okay.
your ball becomes slower and slower. But we consider moving up as the positive direction. So if the velocity is positive, right, then the acceleration will be negative. The
Negative. Okay.
acceleration will be negative. So actually you are moving slower and slower because of the gravitational attraction. Okay, now because you are moving slower and slower, it will come a time when the ball will stop. It will reach its maximum height. So it will stop. So let's say this is the position where the ball stopped and the velocity is 0. Now
Mm-hmm.
after stopping, the ball starts to drop down. Okay, it starts to drop down. Now
Okay.
at the very top here, the velocity is 0, but it is only 0 at a very short moment. So we call it instantaneously at rest or instantaneously 0. It is only at that particular instant. It is not 0 all the time. If it is 0 all the time, that means the ball will be floating in the air like that, stopping there and not coming down. Okay, not? So it is only
Mm-hmm.
0 for a short while, for that instant only. So we call it instantaneously at rest.
Okay.
So this is the upward journey of the ball. Okay, so I'm reading from here. The ball is
Mm-hmm.
moving up, the acceleration is acting down until it reaches the maximum height. Okay, right. There, the ball is instantaneously at rest. So actually, if you look at instantaneously at rest, it is actually referring to this question C here. An object with constant non-zero acceleration.
Non-zero. Okay.
Non-zero acceleration means the acceleration due to gravity, the g which is pulling the ball, it is there all the time and it is not
Oh,
zero,
okay, okay, okay.
right? Probably it is 9.8 meter per second square. Okay, now non-zero can never stop and remain at rest. An object with non-zero can never stop. So can never stop. It will stop, right? It will stop. It will come at the time when it reaches the maximum height, it will stop. And it will remain at rest there. No lah, it's not true again lah. It won't remain at rest there. It will fall back to the ground. It will fall back to the ground. So
Okay.
this one is the C is false. Answer for C is false. So
Okay.
it
Mm-hmm.
can stop but it will not remain at rest all the time. Okay. Now let us look at this B again. This B again. Slowing down. Now this slowing down here is actually referring to the example, the same example, but instead of accelerating, I'm going to consider this car slowing down. But you call it deceleration or what? Have you
Deceleration or spin.
deceleration? When the negative acceleration, you call it deceleration, right? Okay. So
Mm-hmm.
now Eh, Now let us consider this car here. Where let me make this one get by this one. Okay, this I'm looking at this one here. Okay, slowing down. The velocity and the acceleration in opposite direction. Now, what does this mean? You see, the car is moving from left to right, left to right. Now, it is slowing down. At first, 20 meter per second. Finally, it is 10 meter per second. So it is actually slowing down. And we say that the the velocity of the car and the acceleration, they are in the opposite direction.
Okay.
Because it is slowing down, so the acceleration is in the opposite direction. So it's actually a deceleration. It's actually a negative acceleration. Okay, so this is the case, what they mean by velocity and acceleration in the opposite direction. Is
Okay.
this okay?
Yeah, yeah.
It is slowing down, that means the velocity and the acceleration, they are in the opposite direction. Now, we look at the second case. The second case, both, okay, the car is
Mm-hmm.
moving in the negative direction. At first, the velocity is negative 20. Finally, the velocity is negative 5. Now, this shows that the car is slowing down.
Okay.
Okay, the car is slowing down. But it is slowing down in the opposite direction. Okay, it is slowing down in the opposite direction. Now the velocity and the acceleration, they are in, both of them, they are in the opposite direction. The velocity is moving in this direction, the acceleration is there, it is going against the velocity, that's why it is slowing down. If the acceleration and the velocity, they are together in the same direction, then they will increase, the speed is increasing. Velocity and
Mm-hmm.
acceleration in the same direction, the velocity in the same direction, then the speed is increasing. Okay, it is increasing. Now, if the velocity and the acceleration, they are in opposite direction, it means the vehicle is slowing down. So both in these two cases, okay, both cases, the car is slowing down. The acceleration in this direction, the car is moving in the other direction. In the second
Okay.
case, the velocity is in this direction, the acceleration is in the opposite direction. So that is what they meant by velocity and acceleration in the opposite direction, they are slowing down. Okay. So is it possible for a car to have a positive acceleration when it's slowing down? Now, both
Yes.
of them is slow. This is slowing down. This is also slowing down. Both of them slowing down. But because of our direction, okay, because our direction, this acceleration here is positive. This
Mm-hmm.
acceleration here is positive. This one, the first one. Then the second
Yep.
one, sorry, not this one. I better clear this. Actually, it's the other one. Okay, I clear this. Right. Now, this direction, this acceleration is from right to left. So this acceleration is negative. This one is negative. 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 Right. Now, this one, the acceleration is going from left to right. This acceleration is positive. The second case is positive. Okay, right. So both of them in the opposite direction, the velocity and the acceleration in opposite direction, yet the acceleration is positive in this case. You think about this again, then you try to ask me question. You think about this again. The positive and negative sign is very confusing. The positive and negative sign is talking about whether they move from left to right or right to left.
Positive sign is from
The sign.
right to right to left.
The positive sign is from left to
Right to
right.
left.
The negative sign is
Eh?
from right to left.
Oh, okay.
Whether it's velocity